Okay, Assalamualaikum. Welcome back, guys, to my channel. So, today we're gonna continue our discussion. Last time we met, we are still working on question number 12, right? So, number 12, like what we discuss is about the calorimeter, okay? Just remember, we are still discussing the chapter about heat and enthalpy. Okay, and as I mentioned before, we need to like remember kind of like some equation that we need to know for each type of equation. And yeah, let's do it more for the rest question. So let's take a look at number 13. Okay, the molar enthalpy of formation H2O is this one. Okay, which expression describe the enthalpy change for the reaction? Okay, the change of reaction. Okay, so as you can see, the molar enthalpy for H2O is minus 20 blah blah blah. Which expression describe the enthalpy change for the reaction? Okay, so this one is not formation, but uh, the reaction is okay. The re the so as you can see, the reaction kind of like reverse reaction. Okay, reverse reaction, or I mentioned like uh reverse, yeah, reverse reaction. So first of all, we need to know how looks like the formation of H2O. So just H2 and then plus 2H2 plus O2, and then it will be 2H2O. Okay, so from this equation, the H2O formation is minus 2A5. So just we need to only times this one with 2, kind of like this. Okay, so however, because of the reaction is reverse reaction, not like this one. Okay, the reaction should be kind of like this. Okay, however, the question asking about kind of like this equation, so simply we need to just like put in the sign of minus. Okay, we need to put in the sign of minus, so just minus and then HF, and then it should be 2HF. Okay, should be 2HF, so the answer will be C. Okay, all right, and then let's move on another question. The standard enthalpy. Okay, I need to double check the answer first. Okay, I need to check the question, the key answer first. Let me check number 13. Number 13 will be C. Yeah, that's true. The standard enthalpy change for the formation of silver chloride from its element is blah blah blah. Then the enthalpy change for the formation of silver bromide. Okay, for silver bromine. All right, so we need to analyze this one by one. So given standard enthalpy of formation value, okay, delta HF for each value, AgCl, right? And then it is the solid one, right? put in over here, kind of like this, minus 121, and then delta HF HEPR, and then this is also solid, and then what it is, minus 100.4, right? So the standard enthalpy of formation, okay, the standard enthalpy of formation is the energy change when 1 mole compound forms from its element in their standard state. Okay, so the standard enthalpy is the energy change, okay, the energy change when 1 mole of compound, okay, forms from its element. Okay, more negative, okay, if more negative, it's telling us like more negative, it's more exothermic, okay, more exothermic, because exo is exit, okay, more exothermic. Okay, so like greater release energy. Okay, and then less negative is like kind of like opposite, less exothermic and then more endothermic. Okay, so here HCl is more negative. So the standard enthalpy change for the formation of silver chloride from its element is, because HCl is more negative, we can say more exothermic than the enthalpy change for the formation silver bromide, more exothermic. Yeah, that's true. More exothermic. Just remember, guys. Okay, just remember. Yeah, just remember delta HF more negative, which mean more exothermic, because it release more like greater energy. It release greater energy. All right, so number 15. Which reaction represent for Al2O3? Okay, what's the answer for this one? Okay, let me bring it up first. Okay, now move on number 15. Okay, yeah. So which reaction represent for delta HF for Al2O3? Okay, the definition of delta HF is the enthalpy change 1 mole of compound formed from its element in their standard rate states. Okay, for Al2O3, okay, the standard state is, okay, standard is this ALS, right? And then O2 gas, all right? So what we need to know is we need just combine it together, like arrange together, and then the thing that we need to put in over here is it should be 1 mole. It should be 1 mole. Like I mentioned, delta HF formation is 1 mole. Okay, 1 moles. Okay, of compound. Okay, the enthalpy change. Okay, enthalpy change. Okay, when 1 mole forms from its element in their standard state. Okay, standard state. Al S plus O 2 in gas becoming Al2O3. So it will be what? It will be 2Al and then 3 half O3. So the answer will be B. Okay, that's the answer. That's the answer. It's pretty easy for this question. Okay, it's pretty easy for this question. Now move on to another question. Number 16. The standard enthalpy of formation delta HF for NO2 is the enthalpy change for which reaction? Okay, it's still same again in their standard state. So N2 plus O2 becoming NO2. So because N2 here is 2, so we'll be putting over here 2. This one should be 2. So N2. So however, we need to put in here is 1. Okay, so divided by 1. Divided by 2. So NO2 and then O2 and then half N2. Half N2 and then O2 and then NO2. So number 16 is still the same. The answer still B. That's true. Now move on to for question 17. We are given a reaction and some enthalpy values over here. Okay, and then given the data one by one like this one. So what is the standard enthalpy for the reaction of this one? So how to solve this problem? First in first, we need to determine the target reaction. The target reaction is 2NH3 and 2H4 plus H2. Okay, we use the Hess law. Okay, manipulate the given reaction so there's some match the target reaction. And I will be back soon.
Okay, so now let's continue our discussion. So what is the standard enthalpy change for the reaction? So as I mentioned before, we have to determine the target reaction. We will use the Hess law, manipulate the given reaction. So there's some match the target reaction. Okay, there's some matches the target reaction. How to do that is pretty easy. Just like uh just put in just analyze and reverse as needed. Okay, from this one. Okay, from this one. So from the first reaction, okay, for the form, okay, let's see for the third reaction. Third reaction is kind of like so similar, okay? It's kind of like so similar, okay? Because this is N2 and then 3H2, okay? We have NH3 over here, right? So what we can do here is simply we can simply reverse it for this one, okay, to NH3. So I will put it over here. Third reaction, okay, it will be 3 sorry, 2 NH3 and then N2 plus 3H2. So delta H3 will be plus 92. Okay, so now we have same thing in this side, okay, in the left side. However, we need to determine for another parts, okay? So now we have H2 over here. H2. This one also has H2. Okay, and then let's take a look at others. It is this contain something in that's in like in the another side in another place? I don't think so. So just put in the reverse, like the reverse reaction as well. Okay, the uh for the for the second reaction. Okay, for the second reaction. So just put in over here like to, or maybe just leave it. Let me think. Okay, maybe we can do for the first one. Okay, so it might be easier because we know in the first one, as you can see, there is a unique compound. Okay, so we can conclude the first one reverse reaction as well. N2H4 plus O2, right? And then over here N2 plus 2H2O. Okay, so put it over here and then we have 543. 543. Then how about the second one? Okay, how about the second one? The second one, we need to put in something that might be we can do canceling out. Okay, we can to cancel out. Okay, we need to cancel out something, right? Because we want to eliminate one by one. Okay, let me think how to put in over. So let's do for the third and then the first one. Okay, and H3, so we can cancel out this one with this one. Okay, and then okay, so we have a clue here, H2O. We need to cancel out the H2O because there is no H2O compound in the target reaction. So how to do that is simply it's simple, just putting the same thing kind of like for the second reaction. O2 plus 2H2. And then we cancel out again H2O, right? And then as you can see over here, delta H2, it will be what it is. Minus 484, right? Still same thing. And then this one again, and then this one again. Okay. So now, after we collecting together and then add and cancel, we now sum all three together. Okay, we now sum all three together. 2NH3 becoming N2H4 plus H2. So because it just cancel out 2H2, not 3, right? So it's like still have remaining 1. Okay, it has a remaining 1. What it is, the H2, right? So now let's take a look at if we put in plus over here. So we can do like just simple calculation. 92 plus 943 minus 484, which is we will ended up getting something over here. So the the answer will be 151. Okay, the answer will be 151. Mm, I need to get my calculator. Okay, 92 plus 543 minus 484, 151. Okay, so correct number 17, the answer is C. Let's move on for the next question. Given these values, delta H, in the table, what is the value of delta H for the reaction? Okay, so the same thing, right? The target reaction, we need to determine the target reaction, and then we can manipulate for the equation from the equation provided, right? So let's take a look at the first step. We need to rewrite for the was that the target reaction. So just to make it easier for us to to navigate our answer, just rewrite it over here. Okay, so now let's take a look at which one that unique for each reaction, each compound. CS2, CS2. So I believe CS2 should be the same one. CS2 for the first reaction, right? The same one. CO2, CO2, 2SO2. And then again for the second reaction, which one that unique? H2O2. This one is unique, right? Unique. Okay, there is no another thing over here. So we can conclude this one, just put it over here, minus 0.77. Okay, and then for the second reaction is we reverse it, H2O2 becoming H2 plus O2. Okay, and then it will be 108. So now let's take a look at for the third reaction. So usually the third reaction, uh the third reaction kind of like we need to use it for what can I say, to cancel out. Okay, okay, so uh We need to manipulate for the third reaction, okay, to function kind of like cancel out, okay, to be in action, to be in action, or to do, or to run, or to operate, canceling out. All right, okay, so now put in over here which one that we need to cancel out. Probably because there is no H2O, there is no H2O in the left side. I think is better this one, also unique, right? H2O. We can put in over here H2O. Okay, so we do not need to reverse it. Okay, just put in the kind of like in the original one. All right, so now let's process it. Let's process it. Okay, add and cancel all three steps. Okay, add or cancel in for all three steps. Let's take a look at this one. Oh, H2, H2. Okay, we cancel out the H2. This we can also cancel out this one as well. So now we have like half, right? Half O2. That's great. And then what else? What else? We can cancel out this part again. So we have two half O2, right? So now H2O2. How about the CO2 and then two S2O2? Yes, let's take a look at. However, we need to cancel out. What can I say? Maybe we can cancel out with the. Okay, we need to cancel out this part for 302. 302. I believe we can do it. 302. Because it's still remaining O2, that means not good. 302 over here is O2, right? So because of in the target reaction is it contains 6 H2O, we can put it over here 6. 6 and then over here 6 and then we can times 6. Okay, times 6. How about the other for H2O? H2O also 6. We can put it over here 3. We can put it over here 3. All right, that's good. That's good. So now let's take a look at the answer. Okay, and then we don't forget put in here 6 as well. And then we can cancel out this part. Okay, it's already same, right? No, it's not same. It's not same. It should be same. It should be same. Oh, wait. Oh, yeah. It should be 6, right? Yeah, that's great. So we can cancel out this one, cancel out this one. Okay. How about the O2? O2 is, this one is 6, right? And then this one is 12. So we cancel out for 6. Okay, cancel out this part and then remaining 6. And then this one 6 and then we cancel out this one 6. So that's great. So now we already got the target reaction. CS2 plus 6H2O2 becoming CO2 plus 2SO2, and then we are adding H2 again. Okay, H2 again over here. 6H2. Oh, yeah, that's great. So now just like this way, and then 6 times 188 plus 6, kind of like this, right? So let's take a look at the answer. Plus 6 times what? No. and then minus. Okay, the answer will be minus 1665. Oops, 1665. Okay, the answer will be 1. Okay, that's great. And then again and again and again. Now, what's the value of this reaction? Okay, same thing. Okay, just plan the strategy. We need to form like water from hydrogen and ozone. Okay, so just do kind of like same thing. And then let's see H2O, which one that contains H2O. Okay, so H2 plus half O2 H2O, and then we need to cancel out the ozone, so we need to reverse this part again. Okay, now remember this part is should be times 3, and then it should be 3. If we have half, so okay, 3 half, 3 over 2, right? And then over here is also 3. And then this one should be divided by 2, so this one is divided times 3. So this is like this one, and this one. Okay, so that's great. So just cancel out. Oh no, we need to cancel out this one. Okay, so done. So we have 3H2 plus O3 coming 3H2O. So now just this one times what? Minus 820. This way, like this way. How about this one? This one, it will be minus 271 divided by 2. So the answer will be what? The answer will be 993.5. Yeah, that's very good, very nice. Same thing, guys, same thing. Same thing for number 2020. So let's move on to another question number 2020. So yeah, sometimes the question is pretty easy, sometimes not. Okay, so for this one again, we need to it seems kind of like just same thing. There is no uh another thing that make it more complicated, just same thing. Let's do it. 2 and 2, and then plus I start from the third reaction. Okay, from the third reaction, because I can see directly, I can see immediately the third reaction will be there is a unique 1 and 2 over here, so I just put in the same, I like the original one, 2 and 2. And then so we need to, so the this one is, let me put in here first, and 2 3O2 plus H2 2 H and O3. So now just times what times 2 6 2 4. Okay, that's good, that's great, that's great. There is no issue at all. Okay, now let's move on. Okay, let's take a look at for the first reaction. For the first reaction, we need to reverse, and then times 2. Okay, so it will be 4NH3. Okay, so we use, here is times 2, and then reverse, right? And then this one, it times, just times 2. Okay, again, and AO3, and then 2. Oh, 2N2O5 plus H2O. And then for the second reaction, it will be, we need to cancel out H2 over here. So just putting reverse, right? Reverse. So it might be what? 2H2 plus O2, 2H2O. Now we need to make it easier to visualize for each part. So this one just minus 30, this one times 2. How about this one? 4NHNO3. 4NHO3. Oh, where is that one? This is for the first reaction. Okay, so just times 2 and then reverse sign. Okay, we put in the opposite sign and then times 2. And then how about the second one? $572. Right, that's great. That will be great. Cancel out. Whoop, 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 whoop. Ooh, 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 H2. Cancel out H2. How about the O2 here? Mm, 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 mm. Okay, so first the equation 1, just reverse, right? Just we need to reverse. Why? It's kind of like weird for number 20. Okay, for the equation 1, it will be 2. Okay, 4. Equation 2 will be 2 again. Same, so and ew. What's wrong? What's wrong? Number 20. So we will have N2. Which one? So I think I make a mistake. Okay, minus 696. It's already great, I think. Okay, let's take a look at in detail again. So we have 2 and 2. We have 5. Oh yes, that's great. We have 5. Oh, 2, 5. Yes, that's great. 4 and AU3 is already cancelled out. Okay. This is H2O, right? H2O. Need to cancel out with this one. But why? Oh, it should be 2, right? Okay, okay, okay. That's why I'm confused. Yeah, sometimes kind of like this one, guys. So looks more complicated, and then we need to very careful when doing manipulation stuff. So the answer is like this one, and this one. So just the net one is 29. Okay, let's take a look at again. Minus, okay, 76.6 times 2 plus, yeah, 29.2. 29.2. Okay, one way to produce H2 for fuel cell is to react methane with steam. How much energy in kilojoule is needed? Blah blah blah. Same thing. There is no like a new one over here. So it's pretty easy because it's just 2, right? So this one will be same. This one will be same. Okay, right. Both are still same. There is no change. Okay. So we need to cancel out. Hmm. No, we don't need to cancel out something. We need to just cancel out gas over here. Oop. Yes. And then we getting ended up CH4 plus 2H2O, CO2, and then 4H2. Is that correct? Yes. And then this one just plus, so it will be 5. Right? And then I mean it will be A, right? And then 6 6 5 um oh, let me wait, is that correct? 106. Yes, it will be plus, the answer will be D. Number 20. Oop, why 21? 21. How much energy in kilojoule produce 1 mole? The question is 1 mole hydrogen. Oh, 1 mole of hydrogen. Remember, this one is so important. 1 mole of hydrogen. So yeah, we already ended up getting 198, 168.4, and then divided by, because it has 4, it should be divided by 4. So 41.2. Yeah, the answer will be 41.2 because it contains 4 hydrogen. Okay. So now take a look at this one. Still same. We can skip this one. What is the standard of formation in H3? Okay, now is kind of like different. Okay, now kind of like different because we number 22, 23, right? Yeah. Now we have kind of like different for this one. Because oh, okay. The first and the second is different. Again, put our difference. Okay, so now the target is, oh, this one is still same. We don't need to solve it again because of what? Because we have the same thing. There is no change over here. I mean, the concept still same. Now we move on to 23. Like given the combustion ammonia, okay, blah 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 blah. This is the equation, the balance equation, right? And then there is a standard Hess law. Okay, standard enthalpy of formation delta HF for each compound. And then now use the Hess law again. And then use the Hess law that what's standard formation of NH3. So N2 plus H2, right? And then it will be what? It will be N and and 2 like NH3 2. And then put it over here 3 over this one is 2. Okay, so remember, just remember for standard enthalpy of something is kind of like what we want to know is use the Hess law, write the equation for NH3. Okay, so after that what we want to know, because we only have this information, right? NO2 and then H2O. Okay, but in the given reaction for NH3 is involved. Okay, over here NH3 is involved. Okay, let's express all enthalpies per 4 mole. Okay, per 4 mole. So for NO, for example, for NO, it will be, right? It will be, because this one is 1, so we need to times 4. Okay, 9 and 3 times 4. Okay, so for this one, the delta AH formation, is for N2 plus O2. It will be what? 2 and O. Okay, 2 and O. So for this one, for each NO is 90.3. For 4, it will be 361.2. How about the H2O, the delta AH for H2O? H2O2, it will be 2H2O. Okay, 2H2O. It will be 2 over here, right? And then this one, it will be what? It will be minus 24.8, right? Times, right? Times what over here? However, this one is H2O. We need to find out for what can I say? For just one. Okay, for just one. So as you can see, guys, that let me think. For H2O, for 6 mole, what's the 6 mole? H2O over here is 6, right? H2O over here is just 2. For 6, we need to times 6, right? So we get minus like this one. Okay, so now apply the Hess formula. from the Hess formula is product. Okay, product product minus reactant. Okay, and then we will kill delta reaction. Okay, so now the delta reaction is minus 94.8 kilojoule. And then for the product, we have this one minus uh like this one like resultant, like the sum all of the product and then sum of all of the reactant, minus 450.84, and then plus what it is, mm, plus NO. How about the NO? NO itself, because it's 361.2. Okay, 361.2, and then minus reactant. We want to know the reactant itself, right? So based on this information, we will getting something over here. However, remember over here the NH3 is 4, so we need to determine kind of like this 4 eggs. Okay, so let's take a look at go. Okay, 10 egg minus, right, 904.8. So now how to determine that one is easy. Just you can put it over here, right? 4 eggs. This is minus, okay? So 4 eggs, it will be 10 egg point egg plus 904.8 904.8 divided by 4. So x will be 46. Okay, the answer will be P. Number 23 will be P. 46. Number 23, 46. Yeah, P. That's great. That's great. So just remember the strategy is like use the Hess law, okay, to write down for the formation for NH3, and then write all formula equation and then apply Hess law formula, which is product minus reactant. All right, now we move on to number 24. Use standard enthalpies or formation in the table to calculate delta H xn for this reaction. Blah 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 blah. So now let's take a look at, we want to calculate this formation. Just remember product minus reactant. And then over here is delta HRXN reaction. Okay, now just take a look at for H2O. H2O is 1. Okay, it's simply just put in 1, no need to reverse sign or other stuff, plus CR, this one also minus, and then minus again over here, right? Okay, how about the reactant? How about the reactant? CrO4, but it should be times first, right? And then how about this one? H2 will be 0. Okay, so it's done. 2 8. Okay, and then get this one minus 1 2. So the answer will be 13.7, but the sign would be Will be minus. Yeah, will be minus. 24 is C, right? 24 will be C, the answer. Let me check. Yeah, that's true. And then again for number 25. Calculate the enthalpy of combustion of ethylene, okay, and 1 atmosphere of pressure. Okay, now the ethylene here is same, right? I mean, the ethylene is same. It's kind of like just 1 mole. But the question is about the combustion. Okay, the question is about the combustion. How to solve this part? Same thing, okay? Same thing, kind of like what? Kind of like the previous one. Okay, calculate the enthalpy of combustion. Delta H or Xn product minus reactant. So now just put in product 2 CO2, so 2 times this one, right? And then again, what else? CO2, CO2, 2, okay, so it will be minus 2 times what? 390, this one, right? And then minus again for the reactant C2, and then this one is just 1. So the answer will be, if we plug in, okay, if we plug in the values, right, for this one, then calculate that one, we will get added up minus 1410.9. Okay, so the answer will be A. That's great. Number 26, use the given hits formation. Again, this one is same. There is no kind of like the specific thing we need to know. Still same, just do math and other stuff. Yeah. We'll use the given hits formation to calculate the enthalpy change for the reaction. Again, still same. Okay, still same, delta H, product and reactant. Okay, delta H, product and minus reactant. So it will be for the product 2 PCl3, so just minus 4, 3, 8 times 2, right? And then 3 CO2, it will be minus, yeah, minus 393.5 times 3, minus for the R, but the reactant is minus 20, yeah, like this way. And then minus 3 times, okay. Now we getting ended up, the answer will be 50 minus 58.9. Yeah, the answer will be C. Okay, that's great. And then again, using the thermochemical data, still same. There is no kind of like new thing. We can skip this one because I assume you will get that one. Okay, for the next question, number 28. Okay, now it is kind of like I think still same, right? As long as we know this one. Is it the aqueous? Yes. So remember, O2 is 0. Okay, remember O2 is 0. Always 0. Okay. Okay, let's see. Let's see for the product and reactant. Okay, the enthalpy of formation elemental mercury, okay, and silver are put 0 because they are standard state. So delta FAG aqueous and then aqueous. So for the solid and liquid, we can assume put are 0. That's interesting. Okay, we can assume put are 0. So let's take a look at again. Yeah, we need to deal with this problem. Okay, so now Ag aqueous. Ag aqueous. It should be just same thing. Product and then reactant. Product minus reactant. So the product will be to Ag, it will be 2 times, oops, 2 times 105.6, right? And then plus, no, wait, no, wait. This one, it should be 0, okay? So the product will be, what is that, 101 minus what? 2 times 105.6, and then plus 0. Then this one also plus 0. Let's see. Minus 40.2. Yeah, minus 40.2. That's great. The answer, number 28, will be C. Yeah. Again, if there is no information, just assume that was 0. What is the enthalpy of hydrazine? This one. This one is 3. What we want to want is just 1. Remember, just 1. Okay, so NH3 is this one. Okay, and then NH3 here is 4. So it will be like delta HR, or reaction, resultant of product minus reactant. So for the product, it's just times 4 minus, okay, and then N2 we can assume this one is 0. And then this is that we want to know, but remember this one is should be 3x, and then reactant is 336. Okay, so now just putting together, minus 46.3 times 4, it will be this one, minus 3x 336. Okay, and then now is 3x, this one, plus 336. Okay, oh, this one is minus, right? Yeah, plus 336. So 3x 150.8. So x will be what? X will be 50.26 plus. So the answer will be C. That's great. Yeah, that's great. And then let's move on to last part. What is the standard enthalpy for this reaction? MgCl, HCl. Okay, we can assume this one 0, 0. And then still same thing, MgCl2 like minus 6416, no change. And then to HCl just minus 2 times This one. So the answer will be what? 641.6 divided minus 2 times, oh no, plus 2 times. So the answer is, oh, it should be minus, right? Should be minus. So 641.6. This one is already minus over here, so it should be mm, 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 mm. Yeah, minus 2 times, so 300.7, but should be minus. It should be minus. Yeah, good. Great. We done for the enthalpy and then heat. Okay, we done for this one. So for the next part, I will teach for bonding reaction. Not bonding. I mean, what's the title of the next part? Let me check it first. Okay, structure and bonding. Okay, for the chapter 7. Okay, well done. So bye bye. We will meet